Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 1 Sets, Relations and Functions. Topic Functions. Subtopic Functions as a special kind of relation from one set to another. Domain, codomain, and range of a function. Diagrammatic pictorial representation of a function. Real value function of a real variable and their domain and range. Some specific functions and their graphs including constant, identity, polynomial, rational, modulus, signum, and greatest integer function. Some difference, product, and quotients of real value functions. Exercise 2.3. Function. Let us define what is a function. A relation f from a set A to set B is said to be a function if every element of set A has one and only one image in set B. Adagi B da oiba f haiba relation asi function haigani. Agi element khudingi B da corresponding image amakhattamak lairabadi, or a function f is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no two distinct order pairs in f have the same parse element and denoted by f from A to B. F is a function from A to B haina pagani. A B da oiba function ama haibasi A B da oiba relation amani. Domain of f asina A oiraba f ki any two order pairs ki first component amatta manadrabadi madubu aikoina A B da oiba function ama kawe. Masibu f such that A arrow B haina igani paba matamda f haibasi A B da oiba function amani. Remarks. A function is a special type of relation. Function nama haibasi relation sing manungdagi yamna special oiba particular type of relation ni. There are many terms such as map or mapping used to denote a function. Function ki equivalent word yamna lai map natraga mapping haigani. Image and pre-image of an element of a function. Karigumba function namagi element amagi mami amasung pre-image haibasi karino yengsi. If f is a function from A to B and order pair AB belongs to f, then f of A is equal to B, where B is called the image of A under f and A is called the pre-image of B under f. F haibasi A dagi B da oiba function ama amasung AB haiba order pairs in F yauba order pair ama oirabadi f ki mami a f a ga b ga lainariba mari asibu f of a equal to b iraga khangnai. B asibu a gi function f ki makha doiba mami kawi, a asibu na b gi function f ki yengnaruba da pre-image kawi. Domain, codomain, and range of a function. Let f is be a function from the set A to the set B be a function, then the set A is called domain and the set B is called codomain of f. The set of all f images that is set consisting f of x such that x belongs to A is called the range of the function f. Real function. A function whose domain and range are the subsets of the set of real numbers is called real function. Domain amasung range animak set of real numbers ki subsetting oiba function amabu real function kawe. Working rules for finding domain of a function. Function amagi domain puthoknabagi working rules sing. Ahanbada, find all those real values of x for which the function y equal to f of x is defined. That is, y is real. Y bu real ohinba x ki value pumnamak real oiba value pumnamak putu ahanbada. Anisubada, for algebraic function, the denominator should not be 0. Algebraic function ki damakta di makhagi denominator to 0 oiba yade. An expression under root ki makhada leiba radicand adu should not be negative oiba yade. Condition ani sing kadabani algebraic function sing ki damakta de. Working rules for finding range of real function ki range puthoknabagi working rules sing. First, find the domain of y equal to f of x. Piriba function adugi ahanbada domain puthu anisubada since y equal to f of x equal to iso y. Y bu in terms of x the phongdok lambadu x bu in terms of y the phongdok o. Ahum sub step ta find the values of y for x in domain of a. Y ki karamba value sing na x bu f pi domain da yauba value sing tana na bagi damak x na f of domain da leiba value sing oina bagi damak y ki value sing adu putu u oithokpa yaba value sing adu. The set of values of y in step 3 is the range of function a. Step 3 da leihoriba y ki oithok x pu ri domain da leiba value tahanba ngamba y ki value real oiba value sing adu bu range kawi function dugi. 7. Some functions and their graphs. Function khara amasung makhoi ki graph sing. Identity function. A function f from R to R defined by f of x equal to x. X belongs to R is called the identity function whose domain is R, the set of real numbers, and range is also R, that is the set of real numbers. Range amasung domain amasung range animal R or any identity function that karamna define tawi f of x equal to x means 1 na 1 da 2 na 2 da minus 1 na minus 1 da masada map to a function bu identity function kawi. Its graph is the straight line bisecting the first and the third quadrant as in this picture. Picture asini yauribasini line asina f of x equal to x ki graph ni masina first quadrant amasung second quadrant bu bisect tawi tangkhai ta na khai doi origin power. Constant function. A function f from R to R such that f of x equal to k, where k is constant, is called a constant function whose domain is R. The x can take any real number and range is k. Singleton set consisting k only. Maramdi 1 na k, 2 na k, 3 na k, 4 na k, real number pumnamaki mami si k kaktani range codomain yauri ba image si k kaktani adana mahaki range ti set singleton set consisting k only. Its graph is a line parallel to x-axis. Mahaki graph the x-axis the parallel over line ama oigani. K ki value na positive or the line do x-axis ke upward ta x-axis the parallel over. K ki value na 0 or the x-axis orani. K ki value na negative or the x-axis ke parallel over line si makada lairani x-axis ki makada. Polynomial function. A function f from R to R defined by f of x equal to a0 plus a1x plus a2x square plus dot plus an x to the power n, where n belongs to w whole number oigadabani n and a I belongs to R. A I pum number a1 a0 a1 a n khuding mark real number oigadabani is called a polynomial function. Its domain is R, the set of real numbers, and range is also R. The graph is y equal to x square. Polynomial function ki di maha ki di pak chawbanina particular y equal to x square haibasi polynomial function ne second degree ki quadratic second degree ki second degree polynomial quadratic polynomial ama ki graph ti maha ki parabola oigane. Resonant function. A resonant function f is defined as f of x equal to px by qx. Qx does not equal to 0, where px and qx are polynomial functions. Its domain is x belongs to R such that q of x does not equal to 0. Polyresonant function ki domain de denominator bu 0 pibangamdaba s ki real oiba value pumnamaktu oigane. Mahaki range di particular pidrabadi puthokpa yadi. Modulus function. A function f from R to R such that f of x equal to modulus x, which is equal to minus x when x is less than 0. When x is negative, its value is minus x, whose value is 0 when x is 0, whose value is x when x is positive real number, is called modulus function whose domain is R and range is the set consisting of 0 and set of positive real numbers. Its graph is traced bisecting the first and the second quadrants and originating from origin. Signum function f from R to R defined by f of x equal to modulus x by x does not equal to 0, whose value is 0 when x is 0. It can be expressed again as f of x equal to minus 1 when x is less than 0, whose value is 0 when x is 0, whose value is 1 when x is 0. Is called a signum function. Its domain is R. That is, x can take any real number, and range is -1, 0, 1. That is, whose outcome, there is only three outcomes, that is -1, 0, 1. Its graph consists of number 1, a ray AB parallel to OX ray, excluding the point 0, 1, that is A. Number 2, a ray CD parallel to OX dash ray, excluding the point 0, -1, that is the coordinates of point C, and the isolated point 0, 0. Origin asisu graph asida yaugani. Greatest integer function. A function f from R to R defined by f of x equal to x within third bracket, where within x within third bracket is the greatest integer less than or equal to x, is called a greatest integer function. This function is also called step function. What does this symbol denote? This symbol denotes that the greatest integer less than or equal to x. If x is any integer, either negative or positive or 0, whose outcome is the integer itself. If this x is a real number, not integer, then we have to find out integers less than that number, and from which the greatest one is its output. Its domain is R, that is, x can take any real number, whose range is the set of integers. Tabulation of f of x within third bracket, whose tabulation is very lengthy. When x is lying between -3, -2, including -3, whose outcome is always -3. When x is lying between -2 and -1, including -2, excluding -1, whose outcome is always -2. When x is lying between -1 and 0, including -1, excluding 0, then whose outcome is always -1. When x is lying between 0 and 1, including 0, excluding 1, is 0. When x is lying between 1 and 2, including 1, excluding 2, whose value is 1. When x is lying between 2 and 3, including 2, excluding 3, is 2. When x is lying between 3 and 4, including 3 and excluding 3, whose value is 3. And we can take a number less than this and a number greater than this, whose graph is as shown in this picture. This is 1, this is 2, this is 3, this is 4, this is 5, so on. This is -1, -2, -3, -4, so on. Whose graph is, let us consider this, x lying between 0 to 1. When x is lying between 0 to 1, excluding 1, including 0, and whose corresponding y coordinate is 0, that is, this darkened portion represents the graph of this. And when x is lying between 1 and 2, including 1 and excluding 2, and whose corresponding value of y is 1, this is represented by this, excluding the right end. And for this we have this, and for this we have this. Similarly, for this we get this, excluding right ends. Thus, the graph of greatest integer function is a line segment parallel to x-axis, excluding the right ends. This function is also called step function. We have seen that this picture shows that this is the staircase. Therefore, it is called step function. Algebra of real functions. Let f is a function from x to r and z is also a function x to r be any two real functions where x is subset of r and alpha is a scalar. Then, number 1, sum of two functions denoted by f plus z. F plus z is also a function from x to r defined by f plus z of x is f of x plus z of x. And f minus b, which is the difference of two functions. F minus b is again a function which is a function from x to r defined by f minus z of x is f of x minus z of x. Next is product. Product of two functions f and g is denoted by f dot g, which is also a function from x to r by defined by f dot g of x is f of x into g of x. Next, multiplication alpha. This scalar alpha scalar multiples of a function is, or this is also a function from x to r defined by alpha of x. G is of x is alpha into g of x. Next, quotient of two functions denoted by f by g or f oblique g is a function from x to r by f by g of x is f of x by g of x, provided g of x cannot be 0. Exercise 2.3. Question number 1. Which of the following relations are functions? Give reasons. If it is a function, determine its domain and range. Makhagi relations sing asi karambana function no function oibasing adudi domain amasung range putoklamu. Roman number 1. 2 1 5 1 8 1 11 1 14 1 17 1. This is a function. Here it is a function as any two order pairs have different fast components. Any two order pairs of this set have different fast components, therefore it is a function. For Roman number 2, 2 1 4 2 6 3 8 4 10 5 12 12 6 14 7. This is also a function. First one, its domain is 2, fast components 2 5 8 11 14 17, and range is second component, which is 1 only. For the Roman number 2, this here the function is this. It is a function as any two order pairs have different fast components. Order learning order pair ani fast component amata manade function ore mahaki domain di, therefore its domain is formed by first all the elements of fast component 2 4 6 8 10 12 14, and range is set by second components 1 2 3 4 5 6 7. For Roman number 3, two order pairs have the same fast component, therefore it is not a function. It is not a function as two order pairs 1 3 and 1 5 have same fast component. For question number 2, find the domain and the range of the following real functions. Makhagi real functions sing a sig domain amasung range putu. For Roman number 1, f of x is minus modulus of x. By definition of modulus x, we get when x is negative, that is x is less than 0, absolute value or modulus of x is minus x. Minus of minus is plus x. When x is 0, whose modulus 0, modulus of 0 is 0, minus 0 is again 0, as 0 is neither negative nor positive. When x is positive, that is x greater than 0. Absolute value of modulus of positive value is x itself, and that we get minus x. Its domain is x can take any negative real number 0, any positive real number, therefore domain is R, and range is what? Modulus of a number multiplied by minus. Modulus of any real number multiplied by minus, we get a negative or 0, up to 0, which is open interval minus infinity 0. For Roman number 2 here, f of x is equal to square root of 9 minus x square. Now f of x is real if 9 minus x square is greater than or equal to 0. Radicand is greater than or equal to 0, then f of x is real. Solving, we get 9 greater than equal to x square. Solving, we get x to be lying between minus 3 and 3, including the 2. Therefore, domain is the closed interval minus 3, 3. For range, let y denotes f of x, therefore y becomes y equal to root over of square root of 9 minus x square. Squaring y equal to square root of 9 minus x square, we get y square equal to 9 minus x square, as well as y should be greater than equal to 0. Remember this portion. If here is minus, in a squaring we get this, and from which we get this, we get it is positive, therefore y should be, the value y should be greater than or equal to 0. Remember this carefully. And solving x for parts equation, we get x equal to plus minus square root of 9 minus y square. For x to be closed interval minus 3, this radicand should be greater than equal to 0. Similarly, above we get 9 greater than equal to y square. Solving modulus of y should be less than or equal to 3. That is, but y should be positive or 0. Y should be positive or 0. This shows that y should be lying between minus 10 to combining these two, we get y should be lying between 0 and 3, including day 2. Therefore, all those possible values of y which x belongs to this its domain is the range. Therefore, range is 0, close interval 0, 3. Question number 3. A function f is defined by f of x equal to twice x minus 5. Write down the values of f of 0. It is very easy. F of 0, replace x by 0 in this side also. 2 into 0 minus 5 is minus 5. F of 7 is 2 into 7 minus 5, that is 9. F of minus 3 is 2 into minus 3 minus 5, that is minus 11. For question number 4, the function t which maps temperature in degrees Celsius into temperature in degree Fahrenheit is defined by t of c is equal to 9c by 5 plus 32. Find t of 0. Replace, put c equal to 0. Put c equal to 0, you get 32. Put c equal to 28, you get this 82.4. Put c equal to minus 10, you get this 14. The value of c when t of c is 18. The value of c when t of c is 212. T of c is 212, it is given, and t of c is this. Solve c from this equation, we get c equal to 100. For question number 5, find the range of each of the following functions. Roman number 1, f of x is equal to 2 minus twice x. X belongs to R. X should be positive. We have to find out range. Let y equal to f of x. Then the above function becomes y equal to 2 minus twice x. Solve x in terms of y. We get this. You can take any real value of y. That becomes x always positive. For x to be positive, for x should be greater than 0. You have this should be greater than 0. So multiply by 3 positive number and equality sign remains unchanged. We get this. Solve y. Y should be less than 2. All those possible values of y is the range. Therefore, range is y should be less than minus 2. Open interval minus infinity 2. For Roman number 2, f of x is x square plus 2x is the real number. You can take any real value of let y equal to f of x equal to x square plus 2. Therefore, now f of x is replaced by y. Therefore, above becomes y equal to x square plus 2. Clearly, x square plus 2 is greater than equal to 2 for all x belongs to R. X na loaning ba real number laurabasu x square plus 2 gi value di 2 amasung mangondagi chawba number ama hekta oirani. Therefore, y x square plus 2 di karana sindokre y na sindokre y should be greater than equal to 2. Therefore, range is y obiya value sungnani close interval 2 left close to infinity open the oirani. For Roman number 3, f of x equal to x is a real number which is an identity function. Clearly, for any real value of x, f of x is always real number. Therefore, range is also R. Thank you for watching video.